Hello, I am Kiran, currently pursuing my engineering journey at Institute of Aeronautical Engineering College. In this tech talk, in Java, you should favor composition over inheritance in Java. Here, why? This is the topic which I have chosen in a Java tech talk. Introduction. So, composition and inheritance are two fundamental concepts in object-oriented programming. In Java, composition refers to creating classes that contain other classes as members. This representation will discuss why favoring compositions over inheritance is recommended in Java. What is composition? So, composition in Java is a design principles that involves creating complex objects by combining simpler ones. It enables you to build more flexible and modular code by composing objects rather than relying solely on inheritance. Ob- uh, in composition, one class contains an instance of another class, and the content class becomes a part of the larger whole. Code reusability. Composition promotes code reusability by allowing objects to be used in multiple contexts. By composing smaller objects together, we can easily assemble new objects with desired functionality. This reduces the need for duplicating code and simplifies maintenance. Flexibility and modularity. Composition allows you to easily modify the behavior of a class by changing or substituting the objects it contains. This is particularly useful when you want to alter or extend the functionality of a class without modifying its code directly. Dynamic configuration. Objects can be composed at a runtime, enabling dynamic configuration. You can switch composition or change the state during the program's execution. Ease of changes. Because of classes are composed of smaller independent components, making changes to one component doesn't necessarily impact the entire class. This makes the code more flexible and less prone to unintended side effects. Modularity in composition. Independent development. Each class and its composed uh, components can be developed, tested, and maintained independently. This modular approach allows for more manageable and parallel development efforts. Loose coupling. Composition promotes loose coupling between objects. Objects are not directly dependent on the implementation details of other objects. This improves encapsulation and reduces the impact of changes in one part of the code on the other parts. The single responsibility principle. Composition adheres to single responsibility principle. Each class has a single responsibility, making it easier to understand and maintain. Inheritance can lead to bloated and tightly coupled classes that violate SRP. Code extensibility. Composition allows for easy code extensibility. New behavior can be added by composing additional objects without modifying existing code. Inheritance. On the other hand, it requires modifying the superclass potentially impacting the children classes. Testability. Composition improves testability by enabling easier unit testing. Smaller modular components can be tested independently, leading to more reliable and maintainable tests. Inheritance can make testings more complicated due to the tight coupling between superclass and subclass. Encapsulation. Composition enhances encapsulation by hiding internal details of composed objects. Clients only interact with the public interface, reducing independency and improving security. Inheritance exposes the superclass implementation details to subclass, potentially leading to tighter coupling. Design complexity. While composition in Java offers benefits such as flexibility and modularity, it also introduces certain design complexities that need to be carefully managed. Here are some considerations. The first one is increased number of classes. As you use composition, the number of classes in your system may increase. While each class might have a specific responsibility, managing a large number of classes can become challenging. And it's important to strike a balance between granularity and simplicity. Dependencies between classes. Composition introduces dependencies between classes, especially when one class is composed of instances of other classes. Managing these dependencies can be complex, and changes in one class may impact other. Dependency injection frameworks can help manage these dependencies. Dynamic composition. If composition is a dynamic where objects can be composed at a runtime, it introduces additional complexity, ensuring that dynamically composed objects adhere to accepted interface and behavior becomes crucial. Understanding class relationships. Inheritance hierarchies often provide a clear understanding of relationships between classes. With composition, relations can be more dynamic, and understanding how different classes are connected may require a more in-depth analysis. Interface design. Defining clear and intuitive interface for composed classes is crucial. Poorly designed interfaces can lead to confusion and increase the learning curve for developers interacting with the code. Configuration management. Dynamically configuration objects during runtime can be complex. It requires careful consideration of how objects are created, composed managed to ensure that the system behaves as accepted. Testing complexity. Testing becomes more complex as the interaction becomes composed. Classes need to be thoroughly tested. Unit testing, integration testing, and ensuring that changes in one class don't break the functionality of the other become critical. To manage these complexities, it's essential to follow best practices in software design, such as a clear and consistent naming conventions, well-defined interface, documentation, and applying design patterns where appropriate. Additionally, tools like dependency injection frameworks can help manage dependencies and simply configuration of composed objects. Polymorphism. Composition allow for better utilization of polymerization. Objects can be composed of different components, each implementation of a common interface. This enables dynamic behavior and improves code flexibility. Code maintenance. Composition makes code maintenance easier and less error prone. Changes in one component have limited impact on the rest of the code base. Inheritance can lead to cascading changes and increased risk of introducing bugs. Performance consideration. Composition can sometimes have a slight performance overhead due to the need for additional object creation. However, modern JVM optimizations can mitigate this impact in the most cases. The benefits of composition often outweigh the minor performance trade-off. Use cases for inheritance. Although composition is generally favored, there are still valid use cases for inheritance. Inheritance is useful when modeling is a relation such as subclassing a general class to create more specialized classes. However, it should be used judicially and in composition where appropriate. Real-world example: many popular Java frames and libraries heavily utilize composition. Spring Framework, for instance, heavily relies on dependency injection and composition to build flexible and modular applications. The Java Collection Framework is another example where composition is used to provide different data structures. Best practices favor composition over inheritance in most cases. Design class with single responsibility and use composition to combine them. Use inheritance uh, sparingly and only when it truly represents and is a relation. Benefits recap: code usability, flexibility, modularity, and loose coupling, adherence to the responsibility principle, improved testability, encapsulation, and code maintenance. And then print card starting, and and there is one main method class. In the main method, an instance of engine, car engine, and an instance of car, my car are created. The car object is constructed with the engine object. Uh, Finally, we start method invoked on the my car object demonstrating the composition. So why composition over inheritance means flexibility and modularity, preventing the tight coupling. These are the reasons why we should favor composition over inheritance. And finally, conclusion. In this conclusion, okay, composition is a powerful technique that promotes flexible and maintainable code. It offers numerous benefits over inheritance, making it a preferred approach in Java. By embracing composition, developers can build robust and adaptable software systems. That's it.